Time. We experience it as a constant flow, a river that moves us from the past, through the present, and into the future. Yet, when we peer deeply into the fabric of the universe, a startling truth begins to emerge. Time may not be what it seems. In classical physics, time is treated as a simple, linear dimension, a parameter that helps describe motion. But in Einstein's theory of relativity, time is inseparably woven with space into a single fabric called space-time. And here, time behaves very differently depending on your perspective. One of the most profound consequences of relativity is that time is relative. It flows at different rates depending on your velocity and your position in a gravitational field. A clock on a satellite orbiting Earth ticks slightly faster than a clock on the ground. A clock near a black hole ticks far slower than one in deep space. These aren't just theoretical curiosities. GPS satellites, for example, must account for relativistic time dilation to maintain accuracy. Without adjusting for time shifts, your navigation system would quickly fail. This idea that time is not absolute leads to a radical proposition. There is no universal now. What you experience as the present may be in someone else's past or future, depending on where and how they are moving. Each observer carries their own slice of time, their own now moment. This has led some physicists to propose that past, present, and future all coexist, that time doesn't flow at all, but rather that we simply perceive it that way. According to the block universe theory, all events, from the birth of the universe to your next breath, already exist within the four-dimensional structure of space-time. You are not moving through time. You are inhabiting a moment in the block. Imagine a movie reel. The entire story is already there. Every frame, every scene, every ending. But as observers, we experience the movie one frame at a time, giving the illusion of motion and progression. The block universe challenges our intuitive sense of causality and free will. If the future is already written, can we truly make choices? Or are we simply experiencing a deterministic reality, playing out like a script? Some physicists argue that quantum mechanics restores our sense of freedom. In the quantum world, events don't have definite outcomes until observed. Particles exist in probabilities, in states of maybe rather than yes or no. This randomness suggests that the future is not fixed but emergent, shaped by interactions and choices. But even here, things get stranger. The many worlds interpretation of quantum physics proposes that all possible outcomes of every event actually occur in branching parallel universes. In one reality, you turned left. In another, you turned right. In this multiverse of possibilities, every moment leads to a new world. Suddenly, time is not just a line but a tree, branching infinitely into all potential timelines. In this view, the flow of time is simply our consciousness moving through one path among many. Other scientists explore time from the lens of thermodynamics, the arrow of time defined by entropy. The reason we remember the past but not the future is because entropy increases. We see broken eggs, but not unbroken ones leaping back together. This one-way direction gives time its forward bias, even if the fundamental laws of physics are reversible. So if entropy defines our sense of time, could a decrease in entropy reverse it? Theoretically, yes, but such conditions are so improbable in our universe that we never observe them. Even our brains are wired to process time as a flow. We store memories in one direction. We perceive motion as continuous. We make predictions and anticipate outcomes. Time feels real because our biology evolved in a universe where entropy increases and causality works. But what if that's an illusion too? Some philosophers and theoretical physicists now argue that time may not exist at all, at least not as a fundamental property of the universe. It may be emergent, arising from correlations between systems, or from the way we process information. The implications are staggering. If time is not fundamental, then reality may be more like a timeless structure, where all moments coexist and change is simply our perception of moving through them. This perspective may help reconcile the tension between general relativity and quantum mechanics. It offers a new way to understand black holes, cosmology, and even consciousness. In this view, life is not a journey through time, but a location in a vast, timeless landscape. Every moment you've ever lived, or will live, already exists. You are not passing through time, you are part of it. So what does this mean for us? It means that memory, identity, and meaning are not constrained to the ticking of a clock, that the moments you cherish, the laughter of a friend, the beauty of a sunset, the love of a parent, are etched into the fabric of space-time forever. You were there. You are there. You always will be. Perhaps the true mystery is not time itself, but our relationship with it, how we create stories, meanings, and futures from a universe that may already contain all its answers. And if all of time exists at once, then our curiosity, our hope, our drive to understand the cosmos, those too are timeless.